Number 2, we have the graph of the polar equation r of theta is equal to theta cosine of theta for 0 to 3 pi over 2. And it already gives you that dr theta is cosine theta minus theta sine theta as shown. We want to find the maximum distance from the origin to a point on the graph of the polar equation, and we are going to have to justify our answer. So it's asking us for a maximum. Whenever we are thinking about maximums, we are taking the derivative. Here, they already gave us the derivative, so that's great. And what we're going to do with this derivative is essentially set this equal to 0. And find where it is between 0 and 3 pi over 2. So that's what I'm going to do here. So we have cosine of theta minus x sine of theta. And then my window is between 0 and 3 pi over 2. So 0 and 3, 0 and 3 pi over 2. We might need to change my y min and, oh wait, no. Yeah, definitely change your y min and y max because we're only looking at the x-axis. So I would say like -2 to 2 and then call it a day. Graph it, and then remember here, we are just trying to find my zeros for this particular problem. So my first zero is going to be 0.86033. 0.8603. So that's my first zero. And then my next zero is going to be all the way over there. And that's going to give us 3.425. 3.425. Now you might be thinking, why did we include that 0 right there if that right there goes from negative to positive, which is technically a minimum? Well, remember that we're looking at distance. So distance is always going to be positive. So since distance is always going to be positive, I'm also going to include that as a reference point. All right, so we have 0.8603 and 3.425. Now, remember that in order to get credit on the AP exam, you probably want a table of values. And with that table of values, you also want to make sure that you include the endpoints of 0 and 3 pi over 2. So 0, 0.8603, 3.425, and then 3 pi over 2. That's R, and then you have to find out what, no, that's theta, sorry, theta. And then you need to figure out what R of theta is, aka R. Okay, so we already have, actually we don't. What we're gonna do now is put R is equal to theta cosine of theta into the calculator. And that's gonna be Y2. So I'm going to have x cosine of x here. Now, remember that one of the tricks in AP that I taught you guys is if I only want a certain x value here, I could change my table set. So I did second window so that I can do ask. That way, whenever I go to the second table, you don't see anything, and then you could type in your values. So I'm going to type in 0. I'm going to type in 0.8603. I'm going to type in 3.425. And I'm also going to type in 3 pi over 2. Now, what I'm also going to do is probably remove y1 just because I don't really need y1 right here. I only want to focus on y2. So I only have this right here. Now remember that your R value is distance, and it is always going to be positive. So here, this is technically going to be 3.288, which tells me that that's going to be my maximum distance. So this tells me that when theta is equal to 3.425, my maximum distance from the origin is going to be 3.288. Of course, to get credit, you should probably put your little values here. And then that right there. So then this tells me that's my maximum distance is 3.288. Good old absolute max. Lots of fun. All right, part B says find the area of the shaded region between the two loops of the curve. So right here, we want to find the area of the shaded region. So it's basically everything except this little part right here. So what I'm going to do here is go from 1/2 to the whole thing. In this case, it told me that the whole thing is from 0 to 3 pi over 2. So my whole polar curve goes from 0 to 3 pi over 2 of r theta square d theta. It's okay for you to shorthand it because it already gives you that r of theta is theta cosine of theta. So that's what I did right here. And then what I'm going to do here is try to figure out this part right here, aka from here to here, what's my distance? Or what's my theta value so that it makes this little loop right here. So what I'm going to do here is go to my calculator. Instead of using rectangular mode or function mode, I am going to go to mode and then I'm going to click on polar. And then I am going to go ahead and graph this from 0 to 3 pi over 2. So you want your theta to be 0, and then you want your max to be 3 pi over 2. Not 3 pi over 2. Graph it, and then change your bounds if you need to. But I'm going to start at 0 here. And then I am going to trace my way. There you go. Trace my way if I can. Oh, there it is. Okay, I didn't see it. Trace my way through this little loop right here. So here I'm starting at 0, I guess. Let me actually change my y-x meant to be -1 so that I could see it. Okay, so I'm going to have my loop right here. And then it stops essentially right here, so about 1.58. And hopefully you guys know that 1.58 is equivalent to pi over 2-ish. So if I were to do pi over 2, notice how that's going to give me 0, 0. Another way that you could do this is obviously set r of theta equal to 0 and then solve there, but and solve that. But I didn't do that. I just used the calculator to figure out my loop here. So that is from 0 to pi over 2 of r sub theta, r of theta squared d theta. Now notice how we did not have any symmetry going on here, so I'm just going to leave it like this and then not multiply because I don't have symmetry. Now to find the area right here, you are going to have to plug and chug this into the calculator and find out what this is. So here, I'm going to have 1/2 the integral for, oh my beta. We love ads. We have 1/2, and then we go from 0 to 3 pi over 2. And then this is, let's see, oh good, R1. So that's going to be R1 square. And that's going to give us 8.13. So that's the first part. So that's the whole area of my polar curve. Then what I'm going to do is 1/2 the integral from 0 to pi over 2, and that is going to give me the area of the inner loop that I do not want. That's the area of the inner loop. And then what I'm going to do is go ahead and do the area of the whole polar curve minus the area of the inner loop. And that's going to give me 8.004 as my answer. Okay, part C. There is a point on the curve for which the slope of the tangent line to the curve is -2 over pi minus 2. At this point, dy d theta is equal to 2, and we want to find out what dx d theta is at this point. All right. So what we know so far is that this is the slope, meaning that this right here is dy dx, which means that, remember, that dy dx is equal to dy d theta over dx d theta. Lots of good multiple representations in these FRQs, using chain and then using different formulas for slope. It told us that the slope is -2 over pi minus 2, and it also told us that dy d theta is 1/2. So we just got to figure out what dx d theta is right here. In order to solve for dx d theta, I'm going to multiply by dx d theta, and then I am going to multiply by the reciprocal of -2 over pi minus 2. That right here gives us dx d theta. And all you have to do here is just put this into the calculator and then call it a day in terms of what that is, and that's going to be -0.285. All right, part D says find the value of dr dy at the points referenced in part C. The problem is we don't really have a point. The only thing that we know here is that the derivative is this, dy d theta is this, and then dx d theta is this. So in order to find a point, we should probably figure out what theta is. But first, in order to do that, let's see what dr dy is. Remember that dr dy is going to be the same thing as dr d theta times d theta dy. Now, up in part C, dy d theta is equal to 1, which means that d theta dy is going to be 2, if I were to take the reciprocal. Okay, now we also know what dr d theta is, because dr d theta is this thing up top, where we have cosine of theta minus theta sine of theta. So now I have dr dy is equal to cosine of theta minus theta sine of theta, and then times 2. Well, this doesn't really give me a lot of information now. Well, it kind of does. It gives me this. But like I said, we kind of need to figure out what theta is, right? So in order to figure out what theta is, what we're going to use is what we have so far. So remember that dy dx is equal to this lovely thing right here. And we know that dy dx is equal to 1/2 of dx d theta. So -2 over pi minus 2 is equal to 1/2 over dxt theta. Well, remember that we kind of already have a formula for dxt theta. Remember that is going to be negative r cosine of theta plus r prime of sine theta. And that is going to help us figure out what theta is, because that is going to help us with this part right here, because we got to figure out what theta is. All right, so what we're going to do is, of course, put this into the calculator and find my intersection so that I can find out what theta is. In order to do that, we have r, okay, that's good, and then we have drd theta right here. Now this one right here, I am going to go back to function mode so that I can actually find the intersection of this. So now I am going to go to mode, function, y equals, and I have both of them. Okay, great. So, no, I don't really need this, and I don't really need this. What we are going to do is go ahead and plot -2 over pi minus 2 here. For y3, I want that. And then for y4, I want 1/2. And then I want negative r. In this case, that's going to be y2. Negative r cosine of x plus r prime. In this case, that's going to be y1 of sine of x. And then call it a day. Let's see. Theta, let's see what that is. It is most likely going to be, well, it is going to be from 0 to 3 pi over 2. So we are going to change our x bin and x max so that it is between 0 and 3 pi over 2. Then hopefully we could find the intersection. Okay, perfect. So here, I can hopefully do this, maybe. Oh, no, just kidding. So I'm going to do second calc intersection. My left bound's right here. My right bound's right here. This gives me an intersection of 0.7854. So that is going to give me theta. Theta is 0.7854. So theta is equal to 0.7854. Lucky for us, it's already going to store x being 0.7854 and ... So what we're going to do now is just put this into the 84 and then see what that is right there. So drdy is going to be 2, and then cosine theta minus theta sine theta. And remember that this right here, I think, was y1. So let me check. Yeah, that was y1. So what I'm going to do here is do 2 y1 of x. And that is going to give me 0.3034. 0.3034. So this tells me that drdy is 0.3034. All right. Last one in terms of this video, and then in the next video we will do 4 through 6.